Alright everyone, a very good evening to all of you. This is your educator Srishti and I welcome you all on YouTube channel of Unacademy IIT-JAM Live. I hope everything is working fine. My voice and video is definitely working fine. Okay, so I welcome you all on this YouTube session. So what have been we have been doing? We have been just taking journal organic chemistry previous year questions and we are discussing those previous year questions in elaborate format. Okay, so we'll be continuing that series and today I'm going to take some more questions of journal organic chemistry and we'll discuss the context and the crux of that particular question. Okay, so let's take next question. So this is JAM 2021 examination question. Okay, this time question basically I'm taking, right, you must have seen this question in JAM 2021. So let's see how many of you can do this question. Okay, this is your latest JAM 2021 question. Let me write over here. JAM 2021. Okay, and it is MSQ question. What is the question? Among the following, the anti-aromatic compound is or are. Okay, it is a MSQ question, so more than one option is correct. So among the following, which one of the following compounds basically is or are anti-aromatic? Okay, so you have to tell the correct answer. So one of you are watching this session live. If my voice is clear, please let me know in the comment section and please try to solve this question. Alright, so let's discuss this question. Among the following, the anti-aromatic compounds. Okay, now what is aromaticity? First, we need to discuss this aspect. Okay, what is aromaticity? Okay, what are the rules of aromaticity? Definitely, first of all, there should be p orbital conjugation. Okay, there should be alternative conjugation of p orbital. Okay, or we can say that all atoms should be sp2 or sp hybridized. Okay, all atoms should be sp2 or sp hybridized, and the next condition for aromaticity is the planarity. Okay, the compound should be planar in nature. So these are the concepts of aromaticity. Okay, so now what are anti-aromatic compounds and what are aromatic compounds? Okay, so the compounds which follows 4n plus 2 rule, they are aromatic compound. All right, they are aromatic compound, and the compound which follows 4n plus rule, they are anti-aromatic compound. Okay, they are anti-aromatic compound. Okay, so this is the rule of aromaticity. For the molecules which follows 4n plus 2 rule are aromatic in nature, and the molecules which follows 4n rule, they are anti-aromatic in nature. Okay, the molecules which follows 4n plus 2 rule, they are stabilized molecule. Okay, they are stabilized molecule, or I can say their energy is less, right? Definitely if a compound is stabilized, okay, that means the energy is less. And if the molecule is anti-aromatic, so basically it's unstable compound. Okay, it's unstable compound. So now let's see this question and let's try to apply this concept in this particular question. Okay, what has been asked from us, we have to find out the compounds which are anti-aromatic. Okay, let's take this very first option, that is this 4-member ring with 2 double bonds. Okay, so see, first of all, this there is p orbital cyclization. How there is p orbital cyclization? See, if this is a compound, so we can say that this is basically present in plane of your paper. Okay, this molecule is present in plane of your paper and p orbitals are perpendicular to it. Okay, this is how we can just comprehend the statement that this molecule is planar and p orbitals are perpendicular. Okay, so I can draw this molecule like this just for a better right understanding. We can draw this molecule like this, and these orbitals, the one with red color, they are your p orbitals. Okay, they are your p orbitals. So this is how this molecules look like. We have a planar molecule, okay, and we have p orbitals perpendicular to it. Okay, so this is what is known as your conjugation. Okay, you can see we have 4 carbon atoms and we have 4 p orbitals, this means there is p conjugation for sure. So first point is verified that there is p conjugation. Okay, what is our second point? The molecule should be planar. Definitely if there is p conjugation, the molecule is going to be sp2 hybridized over here, and if the molecule is sp2 hybridized, then definitely what is going to be the geometry of sp2 hybridized atoms? Like this. Okay, that means it's planar. Okay, it's planar, so it is sp2 hybridized, p orbital conjugation is present and it is planar. Okay, so all rules are satisfied, then definitely it is a concept of aromaticity. Now we have to figure out if this compound is anti-aromatic or aromatic. Okay, see how many electrons are involved. In resonance we always have to calculate pi electrons. Okay, I'm again repeating it. In resonance we always have to calculate pi electrons. Okay, so how many pi electrons are present over here? 1 2 3 4. We have 4 pi electrons, so definitely 4n is equals to 4, n is equals to 1 over here. 4n is equals to 4, n is equals to 1. This means this molecule is anti-aromatic, right? This means this molecule is anti-aromatic and we have to figure out anti-aromatic compounds only. So definitely A is going to be correct option over here. Okay, I hope this point is clear. Let me know in the comment section if you have any queries regarding this option. Let's go to the next option. A is anti-aromatic over here. Let's take second option. Over here you can see p orbitals are there, right? Definitely all atoms are sp2 hybridized. Okay, so p orbitals are there, so this means it's sp2 hybridized, p orbitals are there, it is following the rule of planarity also. Now what next thing we have to see? We have to count the number of electrons. Okay, how many number of electrons? 1 2 3 4 5 6 7. Okay, we got 8 electrons, so 4n is equals to 8, n is equals to 2. Okay, 4n is equals to 8 and n is equals to 2. So definitely this compound is also anti-aromatic, right? This compound is also anti-aromatic, so option 2 is also correct. Okay, I hope this point is clear to you, right? There is no doubt in this particular context. Let's go to the next option, and if you have any doubts, please let me know in the comment section. Okay, let's take the next question, and this is your next molecule or example. Okay, first of all we have to see the p orbital conjugation. Okay, let's draw this molecule like this. We have a positive charge over here, double bond and double bond, so definitely this is sp2 hybridized carbocation. It must have a p orbital. Okay, it should be having a vacant p orbital, and that is the point of right, the rule of the rule over here, right? This is p orbital, this is p orbital, p orbital, p orbital, p orbital, so we have conjugation of p orbital, so this molecule is planar and definitely we can check number of electrons now. So 1 2 3 4. Okay, 4n is equals to 4, 4n is equals to 4, n is equals to 1. So this compound is also anti-aromatic. Okay, this is also anti-aromatic. Okay, so option C is also correct. Okay, what about this one? What about this one, everyone? Is it anti-aromatic? Is it aromatic or non-aromatic? Anyone? Very good evening, MSD. Is it aromatic, anti-aromatic, or non-aromatic? This compound is non-aromatic. Okay, or not aromatic. Okay, non or not aromatic. Over here we can use both of these terms, but in some questions there is difference between this term and the other term, that is non-aromatic. Okay, why it is non-aromatic? Because you have sp3 hybridized carbocation. Okay, right? uh, are you asking for plus course MSD, or you are asking for YouTube session? Just clarify your query. Okay, so this is non-aromatic, so correct answer would be A, B and C. Okay, correct answer would be A, B and C, and this is your JAM 2021 examination question. Okay, correct answer is A, B and C. Okay, option 4 is going to be your incorrect option. Okay, I hope it's clear to all of you. Great. Let's take the next question now. I hope the explanation is crystal clear to all of you. Let's take the next question. Okay, so this is your next question. What do you think is going to be the correct order? plus. Okay, so I have already started one course, right, general organic chemistry for 2022 aspirants. The course is already running. Okay, you can check out that course on my profile, and from 1st of March, okay, I'll be starting chemical bonding also for JAM 2022 students. Okay, so this one course is already running, and I'll be coming with more courses in upcoming months. Okay, so you can just check my profile from the description box. You can find the courses over there. Okay, so just try out this question. What do you think is going to be the correct order of pK for the following compound? Okay, right. How second one is non-aromatic? Yes, everybody. How second one is non-aromatic? Okay, see, can we consider this molecule as right? Just like we can take azolines, can we consider this molecule as azoline? If I break this bond like this, okay, if I break this particular bond like this, so what's going to happen? Right, this is going to be negative and this is going to be positive. Okay, this is going to be like this and this is going to be like this. Okay, this is how I can break this particular bond. Okay, right, this is how I can break this particular bond. This is going to be negative and this is going to be positive. Okay, so what can I say? This is aromatic, this is aromatic ring. Okay, can I say this is aromatic ring? Right, can I say this thing? This is going to be aromatic, right? And what about this particular ring? Okay, what about this particular ring? This is going to be aromatic or anti-aromatic, right? This is going to be aromatic or anti-aromatic, right? Okay, see, we can apply Craig's rule over here, that is fine. Okay, definitely Craig's rule is also applicable. But if I just consider this molecule as quasi aromatic compound, okay, so definitely this molecule is not obeying the quasi aromatic compound, so we can call it as non-aromatic, right? Definitely we can call it as non-aromatic. Okay, so this is going to be a non-aromatic compound, this is going to be aromatic, this is going to be right, anti-aromatic, and this is going to be non-aromatic. Okay, so this is how you should explain this particular question. Okay, so this is going to be non-aromatic, this is aromatic, this is aromatic and non-aromatic. Okay, I hope now this one is clear. Okay, clear everybody, right? Okay, so I thought, yeah, I think I have said it at right, aromatic, this is going to be non-aromatic, this is going to be aromatic, this is going to be aromatic, and this is going to be non-aromatic. Okay, non-aromatic. I hope this one is now clear. Okay, if I would ask you one particular question, what is the difference between non-aromatic and not aromatic? Anyone? What is the difference between non-aromatic or not aromatic? How we can explain these two terms, non-aromatic or not aromatic? Right. Anyone who could explain me what is the difference between non-aromatic and not aromatic? No, they are not same. Okay, Abhijit, they are not same. The terminology is very different. Okay, not aromatic and non-aromatic. This terminology is very different. Okay. See, let me give you one example. If I give you this molecule, okay, if I give you this molecule, so is it non-aromatic or not aromatic? Is it non-aromatic or not aromatic? If I give you this molecule, so is it not aromatic or non-aromatic? No, they are not same. Okay, they are not same. There is difference in terminology. Not aromatic and non-aromatic, both terms are different. Okay, now it depends on the question, which in which sense we are applying the concept. Okay, if there is no concept of not or non, so we can go with any one of these, but there is difference between not aromatic and non-aromatic. Okay, see what is the difference. If I have this particular molecule, so if I would apply, right, Huckel's rule over here, so it's going to be a 4n system. Okay, but we know number of carbons are more than 7. If number of carbons are more than 7, so this is going to be anti-aromatic. Okay, this is going to be anti-aromatic, but we know that anti-aromatic compounds are not stable in case of 8-membered ring. Okay, so we would call it as non-aromatic. Okay, we would call it as non-aromatic. So this is going to be non-aromatic compound. Okay, this is going to be non-aromatic compound, but over here you can see this is not obeying your Huckel's rule. Okay, this is sp3 hybridized carbon. If this is sp3 hybridized carbon, then aromaticity rule is not followed. If aromaticity rule is not followed, so we can call it as not aromatic. Okay, we can call it as not aromatic. So there's difference between non-aromatic compounds and not aromatic compounds. Okay, I hope now this concept is clear to all of you. What is the difference between not aromatic and non-aromatic? Okay, so let's go to the next one. Clear, everybody? Is this point clear now, Abhijit? What is the difference between not aromatic and non-aromatic? Okay, let's take the next question. Great. Okay, let's take the next question. Now the correct order of pKa for the following compounds. Okay, what is pKa? Can I say pKa is minus log of Ka? Okay, can I say pKa is minus log of Ka? So definitely pKa is inversely proportional to Ka, or can I say pKa is inversely proportional to acidity? Right? Okay, now how I am going to just correlate the concept of conjugate base. Okay, so can I say acidity is directly proportional to stability of conjugate base? Can I say acidity is directly proportional to stability of conjugate base? Okay, so we have to check the stability of conjugate base. If stability of conjugate base is more, so base is going to be weak. Okay, if stability of conjugate base is more, so weaker is the base. So weaker is the base, stronger is the acid. Okay, so if stronger is the acid, so more is going to be Ka value and lesser is going to be pKa value. Okay, so this concept we have to apply over here. So we have to check the stability of conjugate base. Okay, what we have to do, we have to check the stability of conjugate base. Okay, so this is going to be conjugate base, this is going to be conjugate base, this is going to be conjugate base, and this is going to be conjugate base. Okay, so C double bond O negative is going to have a negative charge. Okay, now we know carboxylic acids are more acidic than phenols. Definitely they have pK value of somewhere around 4 to 5. Okay, but phenols have pK value somewhere around 10. So carboxylic acids are more acidic than phenols. Okay, so definitely these two molecules will have more Ka value than 1,2 molecule. Okay, these molecules are going to have more Ka value than 1,2 molecules. Okay, so now we are going to compare this molecule and this molecule. So what is going to be difference in third and fourth molecule? There is major difference. Okay, there is one major difference between third and fourth molecule. Over here you can see the negative charge is on oxygen, over here also negative charge is on oxygen. Okay, first point that you have to consider over here, is there is rigidity in this case. Okay, there is rigidity in this case, plus you have electron withdrawing group. First point is there is rigidity, and second is you have electron withdrawing group. So the negative charge is going to be very, very stable. Okay, if negative charge is very, very stable, so Ka order will be third, then fourth. Okay, then this molecule is going to give you electrons by plus m effect. Okay, so if you are giving electrons to this particular molecule by plus m effect, so there is going to be more negative on oxygen, there is going to be more negative on oxygen. Okay, so we can say that first and second. Okay, so pKa order will be second, first, fourth and third. Okay, this is going to be your correct order of pKa. Is it clear to all of you? Any doubts in this concept now? Okay, this is going to be correct order of pKa, second, first, fourth and third. Okay, this is how we'll be looking forward for pKa order. Okay, great. Let's take the next question. Okay, so this is going to be your next question. Okay, people, so what do you think is going to be the correct answer? The homolytic breaking of CB bond is easiest in. All right, let's solve this particular question. See how we are going to apply approach to this particular question. The homolytic breaking. Okay, we have to see the homolytic breaking. So homolytic breaking means one electron is from this carbon. One electron will take this this carbon will take one electron. This carbon will take one electron. Okay, this is what is known as homolytic bond breaking. Okay, now when I'm going to form radicals over here, so what's going to happen? When I'm going to form radicals over here, so what's going to happen? We have to see the stability of radicals. Okay, so radical over here, radical over here. Okay, radical, we have radical over here, radical over here and radical over here, radical. Okay, so which electronic effect is going to right give us explanation of stability of radical? That is hyperconjugation. Okay, hyperconjugation. Okay, so in hyperconjugation we have to see alpha, right, we have to see alpha hydrogens. Okay, so or we can say right, at alpha carbon we should have hydrogens over there, sp3 hybridized hydrogens. Okay, so see what's going to happen over here. Now we have one hydrogen, one hydrogen, one hydrogen, but this is not alpha hydrogen. Okay, so zero alpha hydrogens over here, 1 2 3 4 5 6, so 6 alpha hydrogens. Okay, over here 1 2 3 3 alpha hydrogens, and over here 9 alpha hydrogens. Okay, so the correct order of stability would be D. Okay, then we would be having C, then B, then A. So this is going to be our correct order of stability. Okay, I hope this point is clear to all of you. Great. Any doubts in this particular context? Okay, let's take the next question. All right, let's solve this question. So the correct order of boiling points. Okay, we have to find the correct order of boiling points. Okay, so what is the very first point for boiling point order? That boiling point is directly proportional to intermolecular forces. Okay, intermolecular forces. Then the second point is boiling point is directly proportional to number of carbons. Okay, then the third point is boiling point is directly or it's inversely proportional to branching. Okay, this is how we are going to explain the point. Boiling point is directly proportional to intermolecular forces, boiling point is directly proportional to number of carbons, and boiling point is directly proportional to branching. Okay, so see, we have OH over here, so there's a possibility of H bonding. We have carbon over here, so there is no possibility of H bonding, but van der Waals forces would be existing. There is OH, so possibility of H bonding. There is OH, so possibility of H bonding. Okay, great. So possibility of H bonding, and H bonding. So this is going to have right, very less amount of intermolecular forces. Okay, so what we can say that definitely this is going to have least boiling point. So second is going to have least boiling point. So we'll be cancelling out option A and option B. Okay, now the next point is, okay, after this intermolecular forces, you have to see number of carbons. Okay, so number of carbons 1 2 3 4. Okay, 1 2 3 4, right? 1 2 3. So definitely this molecule is going to have less boiling point now, so 4. So option C is going to be your correct answer. Okay, then how we are going to compare this and this, right? More branching over here, so less boiling point, less branching, more boiling point. Okay, this is how we are going to this is how we are going to cover this particular question. Okay, I hope this point is clear to all of you. So what all questions we have discussed, let's revise all questions. So we have discussed concept of boiling point, and C is going to be your correct answer. Okay, concept of boiling point we have seen. Then we have analyzed the question of your hyperconjugation. More number of alpha hydrogens will give you stable free radical, and correct answer is option D. Okay, then we have discussed one question on your acidity, that pKa is inversely proportional to acidity. More acidity, lesser would be pKa. So the correct order of pKa would be right, second, then we have first. Okay, then we have fourth one, and then we have third one. Okay, this is going to be a correct order of pKa, right? More acidic compound, less pKa value. Okay, then we have discussed one more question on anti-aromatic compound. So this is going to be anti-aromatic. Okay, this is going to be non-aromatic. Okay, this is going to be non-aromatic. Okay, this is going to be C. This is how we can draw this is how we can draw this particular molecule. Okay, see how we can draw this molecule. If I just change this molecule like this, okay, if I just change this molecule like this, so this is how we can draw this particular molecule. Two fused 5-membered rings. Okay, two fused 5-membered rings. So here is going to be here we will be having one double bond. Okay, and here we'll be having one double bond. Okay, then again we can say that here we'll be having one double bond. Okay, and here we'll be having one double bond like this. Okay, so see, you can see this is going to be a 5-member ring. Now according to Craig's rule, there is no need to apply Craig's rule, or we can say there is C2 axis present. Okay, so if there is C2 axis present, so definitely what's going to happen, that this molecule is going to be non-aromatic. Okay, this molecule is going to be non-aromatic. Okay, so on the same concept, we can just analyze some of the questions also on this particular concept. Okay, when we have two 5-member rings, the compound is going to be non-aromatic. When we have azulene type of structure, okay, how we are going to draw azulene type of structure? This is your azulene type of structure. Okay, like this, we have a 5-member ring like this. Okay, yeah, like this we can draw a 5-member ring. Okay, now whenever we have azulene type of a structure and we have a 5-member ring, so we can say this compound is aromatic. Why this compound is aromatic? Anyone? Okay, why this compound is aromatic? See, what's going to happen over here? There's a double bond over here, double bond and double bond, and there's a double bond over here and double bond over here. Okay, this is your azulene, so we can say that definitely there's a possibility that this compound is going to be aromatic. Okay, so this compound is aromatic in nature. Okay, this is aromatic in nature, this is non-aromatic in nature. And if I would convert this azulene to 8-member ring, so now what's going to happen? Let's suppose we have 8-member ring, or let's start with 7-member ring. Okay, let's start with 7-member ring. Let's suppose we have 7-member ring. So now this compound is this compound will also be non-aromatic. Okay, this compound will also be non-aromatic. Okay, so this compound, that is 5-membered fuse rings and 7-membered and 7-membered fuse rings. Okay, these compounds are non-aromatics because they does not follow Craig's rule. Okay, they does not follow Craig's rule, and this compound, that is azulene, is going to be aromatic compound. Okay, so what's going to be the correct answer over here? The correct answer would be option A and option C. These two compounds are aromatic, anti-aromatic. Okay, they are anti-aromatic, and this is non-aromatic, this is not aromatic. Okay, if I have to use correct statement, so that would be not. Otherwise we can call these two compounds as non-aromatic. Okay, I hope this concept is clear to all of you, right? This is actually your JAM 2021 question. Okay, JAM 2021 question, and option A is, and option C is going to be your correct answer. Okay, so I hope you people found this session useful. If you did, you can let me know in the comment section. If you have any doubts, you can also ask your doubts in the comment section. You can follow me on Unacademy. For that, link is already given in the description box. This is my profile. You can follow me over there. Now, if you want to follow me and if you want to access the content of for JAM 2022 preparation, or MSc Entrances 2021 preparation, or even if you want to study for biotechnology chemistry, okay, so you can definitely get the subscription plus subscription. This is my referral code. You can use this referral code for 10% discount. Okay, and if you have any doubts regarding any topic, you can always message me on Unacademy platform. Okay, just go to my profile, you'll see a message box over there. Drop in your queries over there, and I'll definitely get back to you. Okay, I'll see you in the next class, people. Thank you so much for joining.